In this video, I'm going to describe an experiment that will enable you, with the help of a friend, to measure the circumference of the Earth. There are a couple of restrictions. First of all, you both need to live on the same line of latitude. That means you live north-south of each other. And you also need to live a good distance apart. I think probably 200 kilometers is a sort of minimum value, and anything, well, up to 1,000 or so would be even better. Within reason, the longer the distance, the more accurate the value you'll get. Next, then, you need a certain number of things at each location. First of all, a map of the country so that you can actually measure how far apart you live. Next, a ruler and a measuring tape. Then a straight stick at least 1.5 meters long. The one I use actually is 2.2 meters long. A telephone connection, mobile phone, between the two of you. A compass, it would be useful, but it's not essential. And since we're going to use the sun as part of the experiment, it must be a sunny day. And by the way, just look at the warning on the screen here. Do not look directly at the sun. It can damage your eyes. So what do we do? Well, you each put your sticks in the ground. Now, I've said they need to be at least 1.5 meters long, but they don't have to be the same length. As long as you measure the height of the stick above the ground, L1 and L2. So those need to be measured. You must record those. Next, communicate with your friend and decide when you're going to do this experiment, because you must do it together at the same time. And you must do it when the sun is due south of both observers, yourself and your friend. How do you know if it's due south? Well, you get a compass and you can actually find out when the shadow of the stick goes north exactly from the stick. That's one way. Another way is to find the position of shortest shadow, and at that time means that the sun will be exactly due south of your stick. Next, measure the length S1 of your shadow if you're the location 1, and S2 if your friend is at location 2. And what can you get from that? Well, you can get the angle A1 and A2. It is the elevation of the sun at that point, and the same for this one. Now, in my two diagrams here, this person, whoever it is at location 1, is furthest north if we're doing this in the northern hemisphere. Why? Well, the shadow length is longest there. So we have got now the angle that the sun makes at the same time, that is when the sun is due south at both locations. And now we'll go on to look at the calculations to find out how you work out the size of the Earth, the circumference, from the readings that you've made. Now we've sort of stepped back now to take a larger view. So you can now see the two sticks marked there and there, and because they're verticals, if you were to produce the line onwards from the vertical of each stick, they will meet at the center of the Earth. And you can see the two shadows. This is a much exaggerated version because I've got to show big enough angles to mark. So you've measured angle A1, remember that was at the location 1, and A2, the angle at location 2. And they were the angle, remember, that the sun's rays formed with the surface of the Earth. And therefore, if you look at the geometry of the thing, the difference between A1 and A2 will be the angle where the two vertical lines meet at the center of the Earth. And therefore, we know that angle. But what else do we know? Well, you've already looked up this distance between location 1 and location 2. So we know the angle at the centre of the Earth. We know the length of the arc there, and therefore we know that it's a certain fraction of the complete circumference of the planet. And we'll now look at some actual results. This is the results of a set of measurements that I took earlier on. And for this, location 2 is 1250 kilometers south of location 1. Now, both of them were in the northern hemisphere. Now for the shadow length. The shadow lengths of these meter-long sticks that were placed vertically in the ground at location 2 was 60 centimeters, and in location 1 was 90 centimeters. And remember, they were both taken at the same time. And you can see that the shadow length for location 1, that's the one that's further north, was bigger than the shadow length at location 2. Well, that makes sense because the further north you go, if you're both in the northern hemisphere, the altitude of the sun at the same time is going to be less, so a longer shadow. And here are the angles. For location 2, the sun's rays made an angle with the Earth's surface of 59 degrees, and at the location 1, they made an angle of 48 degrees with the Earth's surface. So this 11-degree difference is equivalent to a 1250 kilometer separation. Well, what about a 360-degree difference? Now that would be going round the whole circumference of the planet. So that distance would be 360 divided by 11 multiplied by the actual distance between my two locations. And therefore the circumference of the Earth is 360 over 11 times 1250, which is 40,909 kilometers. Well, the accepted value is something over 40,000, but remember that this is only quite a simple experiment, and also the Earth itself is not exactly spherical.